fields had to point directly towards the middle of the planet. So there's my arrow for C. The arrow at C should have been the same length as the arrow at A, because they're the same distance from the center of the planet. In addition to that, we needed one more arrow at B. The arrow at B should also have pointed towards the center of the planet, but should have been
Smaller.
shorter, because we're further from the mass that creates the field. That was 2 marks. I'm not quite sure how you could end up not getting those 2 marks. Note that if we look at this question, you're given the orbital direction. All you need to do is add arrows for the velocity and centripetal acceleration of the spacecraft. Well, the velocity is always tangent to the curve, so there's our velocity vector. What direction does centripetal acceleration point?
Center of the planet.
Towards the center. Velocity, centripetal acceleration, all done. We're up to 4 marks. Yes. It's wrong because it's not pointing in the right direction for where the spacecraft is at, as shown in the diagram. Okay? Everybody good? Okay. So, continuing on with this, we also had this. And we did this quiz in class multiple times. You had to draw arrows to represent the horizontal and vertical velocity components for a projectile. What's going to be true of the horizontal components of the projectile's velocity? All the same length. There we go. Probably a good idea to label those. Okay, and if you have a hard time making sure everything's drawn to the same length, put a note out to the side, right? Vertical velocity. Let's hit the vertical velocity at L first. Which the vertical velocity at L be?
0.
0. At K, the projectile hasn't gotten to the top of its motion yet. What direction is it going?
Up.
Up. There we go. At M, the projectile is past the top of its motion. What direction is its velocity?
Down.
Down. How does the magnitude of the velocity at M compare to that at K?
Bigger.
Larger. Because at K it's gotten almost to the top, so it's almost come to a stop. By the time it gets back down to M, it's been falling downward, accelerating downward for quite a while, so it has a larger velocity. You also were requested to put arrows on here to represent the accelerations. What's the horizontal acceleration of a projectile? 0. What's the vertical acceleration of a projectile? Gravitational acceleration. And you should have had arrows here that were all the same length. Everybody okay? All right. Last but not least, in class, I held this diagram up like this and went, hey, there's going to be a question like this on the test. This is the test. See what it looks like? This was 8 more marks available here. And first of all, at a minimum, you should have gone back to the homework and found the problem like this and made sure you could work it. That's a minimum. You know it's gonna be on the test. Okay, I'm not sure exactly what happened here, but I do have to draw this conclusion. For scores with single digits, you didn't go back and read your notes even. You're gonna walk into an IB physics test, you better have gone back and read your notes. I can't think of anything more foolish, really. That's the easiest thing you could do to prepare, is go back and read your notes. If you did not do that, you failed as a student. Okay? You've got to do better than that. If you are going to get a good grade on this, a really good grade, you should not only have read your notes, you should have, particularly for this question, because you knew there was going to be one like this on the test, you should have gone back and looked at this question in your notes from the problems. If it wasn't in your notes because you didn't work it, you should work it. You should look in your textbook and see if there are any more problems like this in your textbook. And where else might you find problems like this? On the past IB test. Go into the past IB tests and look at them. Okay? Find this question. Get together with like 3 or 4 other people and say, hey, it's going to take a while to find this question. Everybody look for it. Let everybody else know when you find it. I'll let everybody else know if I find it.
I gave you.
Okay? Email, text, whatever your communication method of the moment is, everybody else will say, hey, here it is. Maybe take a picture of it and send it via Snapchat. Okay? And then everybody works it and talks about how they got to their answer. That's what you do. Okay? It's pretty clear the number of people with single-digit scores on this that a lot of you didn't do that. Now, that having been said, let's be fair. There are more than a few people as well out there with scores above 20 for their raw score. Okay, that score in the upper left-hand corner is bigger than 20. Good job. Okay, there were 29 marks available. You got more than 20. You did a good job. Okay. If you got single digits, you didn't do your due diligence to prepare for a test. All right? Any questions about this? Now, all of that having been said, guess what we have next? Quiz. That's going to go in your notebook. Guess what we're going to have next time? First thing. A quiz. And where's it going to go? On a separate sheet of paper and get turned in. So before you come into class next time, you might want to study up on these concepts and the past quizzes and your homework. Got it? Okay, ladies